Is there a ninth planet out there? We may soon find out. Our solar system is home to wondrous worlds, mysterious moons, astounding asteroids, and curious comets. But despite myriad telescope surveys of the night sky, most of our celestial neighborhood remains unseen and unknown. That's about to change. Thanks to a revolutionary new telescope, huge swaths of the undiscovered solar system will finally come into view. The Vera C. Rubin Observatory, VRO, currently under construction atop the Cerro Pachón Ridge in Chile, 8,700 feet up, is not merely going to advance the field of astronomy, it's going to revolutionize it. A marvel of engineering, software, and scientific ingenuity, this machine has one overarching goal: to document the entire night sky. This includes distant objects, from convulsing stars to cosmic explosions, but also the countless objects in the solar system that have eluded skygazers. It's going to be a quite complete catalog of everything in the solar system out to and beyond Neptune, says Mario Jurek, an astronomer at the University of Washington working with VRO. The asteroid tally will almost immediately skyrocket. The first asteroid was discovered in 1801. 2 centuries later, 1 million were known. VRO will double that in 3 to 6 months. The observatory may even find the hypothetical Planet 9, a large world that some astronomers believe is hiding at the solar system's peripheries. Probably within the first year we're going to see if there's something there or not, says Pedro Bernardinelli, an astronomer at the University of Washington. And VRO is set to spot dozens of interstellar objects, visiting entities that have been ejected from other star systems. With these exotic shards of space rock, we can literally start to figure out what other planetary systems look like, says Jurek. Over the course of its 10-year survey, set to commence in 2025, VRO will give astronomers a new encyclopedia of the solar system. And then we get to understand what that's all telling us, says Jurek, about the very origins and evolution of our galactic cradle. The Vera C. Rubin Observatory, jointly funded by the National Science Foundation and the Department of Energy, is named after the famed astronomer who revealed the existence of dark matter, an as yet undetected substance binding stars and galaxies together. Designed to address a multitude of cosmic queries, the cutting-edge observatory is a beast of a scientific instrument. Everything is big about Rubin, says Sandrine Thomas, the deputy director for VRO construction. The telescope is super fast. The camera is huge and very precise. The detector is also extremely big. The number of pixels is gigantic. Most observatories have either a wide field of view, meaning they can see more of the sky at once, or a huge mirror, which allows more light to be gathered, revealing fainter and more distant objects. But thanks to its paradigm-shifting engineering, VRO has both. It will peruse the entire night sky viewable from the southern hemisphere countless times during its decade-long survey, seeing almost everything, almost everywhere. This is a once-in-a-generation leap, says Bernardinelli. Beyond the veil. Many of the world's VRO will spot will be in the asteroid belt. This is the mortar left over from planet formation, says Schwamm. The observatory will undoubtedly find many modestly sized asteroids orbiting close to Earth, the sort that have so far eluded asteroid hunting surveys. That means VRO could find future Earth impactors before they find us, so that we can attempt to avoid a catastrophic asteroid impact. Other asteroids may be found drifting inside Earth's orbit, perhaps as part of a hypothesized reservoir of space rocks swimming about close to Venus. And while VRO will populate the inner solar system, it is also set to reveal the architecture of the outer solar system for the first time. As well as increasing the tally of moons belonging to Jupiter and Saturn, the famously ringed planet currently has 146 confirmed moons. VRO will be able to spy comets starting to effervesce further out than ever before. Apart from a few highly volatile elephantine comets, most of these far-ranging ice balls are not spotted until they approach the sunlit confines of the inner solar system, where they heat up and shed a trail of icy debris. VRO may permit astronomers to fulfill a long-time dream: find a comet long before it plunges sunward for the first time in its existence. This would represent a pristine, unaltered record from the dawn of the solar system. With enough advance notice, astronomers could even chase it down before it starts cooking. We'll be able to send a spacecraft to get up close and personal, says Schwamm. Comets come from two places. The Oort cloud, a hypothesized shell of icy worlds at an unfathomable distance from the Sun, has never been directly seen, and VRO won't change that. But the Kuiper Belt, a torus-shaped ring of gelid objects, including the dwarf planet Pluto, will have its portrait taken by VRO in considerable detail. Currently, only a few thousand Kuiper Belt objects, or KBOs, have been identified. VRO is expected to find at least that many. The observations will reveal the true structure and contents of the icy belt, and it could also solve a great mystery about the solar system. How many planets do we have, says Schwamm. Over the last decade, some astronomers have suggested that the peculiar orbits of objects at the solar system's fringes means a Neptune-sized planet is lurking somewhere out there, far beyond Pluto. Existing telescopes are highly unlikely to spot such a distant world, but VRO should find Planet 9, if it exists. Imagine if, 2 years from now, we could say that there's a new planet in the solar system, says Bernardinelli. That's kind of exciting. Visitors from beyond the solar system. In 2017, astronomers detected something amazing. The very first interstellar object, 1I/Oumuamua, a thin asteroid or comet that had escaped the gravitational grip of another star. It moved into and then out of the solar system at remarkable speeds, giving scientists only a few days to study it. Then, in 2019, a second planetary tourist was found, the comet 2I/Borisov. With just two known, scientists have very little information about the nature of such interstellar objects. They remind Schwamm of the corners of old maps that no seafarers had yet chronicled. There be dragons, she says. Fortunately, VRO is projected to find a handful of new interstellar objects every year. These envoys from different star systems contain matter that was forged in stellar and planetary environments different from our solar system. They're a sample of the planet formation process at stars all across the galaxy, says Michelle Bannister, an astronomer at the University in Canterbury in New Zealand. The VRO's sophisticated eye allows it to see objects in a range of colors, which means scientists can not only spot interstellar objects at considerable distances, but also get an idea of what they are made of. And while the VRO plays the role of the reconnaissance scout, scientists can use other telescopes with a smaller fields of view but better zoom-in capabilities to get closer looks at these alien time capsules. If we found one of these things as it was still approaching, and we had a year to observe it, that would be fantastic, says Jurek. Everlasting change. Like all ground-based observatories, VRO will be hampered by the proliferation of low-flying, highly reflective satellites, particularly those belonging to SpaceX's internet-providing Starlink megaconstellation. The roughly 4,500 Starlinks currently in orbit are already adding bright, white streaks to many astronomical images. SpaceX plans to launch tens of thousands more satellites in the future, which could mean 30% of all VRO images would be graffitied. At present, there is no clear solution to this problem. We will have to deal with it because we don't have a choice, says Bernardinelli. But while megaconstellation light pollution will mar some of VRO's views, it won't stop the observatory from being the discovery engine that astronomers have long dreamed about. The detail that will be revealed, this beautiful complexity that's gonna show up, that will fine-tune our ability to go from broad-brush histories of the solar system to something more measured and precise, says Bannister. Currently, as scientists study the outer solar system structure, it's like seeing faces in clouds. The VRO will mean that we have Michelangelo's David. Thanks for watching and don't forget to like and subscribe.